start with this one over here. So I want to start, this is a combination of different types of functions. So over here, we have a straight line and a parabola. And over here, we have a straight line and a hyperbola. And so let's start with doing some questions around that. So what I want you to do for me is I want you to find, we did this in the last lesson, but let's just check the intersection points between F, let me make that a bit thicker, between F and G. Find me the intersection points between these two graphs. And I want everyone to say what, if you're willing to give some tips to your fellow classmates about how to do this, then please put it in the chat. What would your method be or your process to find the intersection points of those two things here? So it would indeed be equate them. Yes. So we go minus 3x minus 4 equals minus x squared plus 2x minus 3. And so now you need to solve for me whether or not there are intersection points. So if I look at a little rough sketch graph, this is an unhappy parabola. And then this is a straight line with a negative gradient. So it's probably going to look something like that. But you need to do the algebra to help me. So I would bring the x squared across, minus 2x plus 3 minus 3x minus 4 is 0. And then we'd get x squared minus 5x. And then we would get minus 1 equals 0. Now this is interesting. Something interesting is going on here. So let's just make sure I haven't made a silly mistake. So x squared minus 2x plus 3 minus 3x minus 4. Now I want to solve this, but this is proving difficult. So I'm going to use the quadratic formula. And if I use the quadratic formula, it's on my formula sheet, and I should get minus 5, and then plus minus the square root of this. B squared is going to be 2 squared minus 4 times a, which is minus 1, times minus 3 over 2 times minus 1. So I'm going to have a 5. Now this thing inside of the bracket is called delta. And the way I'm going to get delta is 2 squared, so that's 4. But then I'm going to get 4. So 4 times 1 is, wait. I'm going to be careful here. B squared is 4. I think I get a negative delta value. What delta value are you getting? So this is the thing inside, which is delta. Minus 4 times a, which is minus 1, times c, which is minus 3. That's going to be positive 3. That's minus 12. 4 minus 12, I get minus 8 inside here. Who else gets minus 8 for delta if they are working this out? Let me know in the chat, because I think I know what's going on here, but I want to see that you guys are getting the same thing. Well, actually, I do know what's going on, but I want you to also see, what does it mean when you solve for intersection points and delta ends up being negative? What do you think, Boitumelo, or what do you think, Irene? So almost, it's not irrational roots, but you're close. If this was a non-square number, it would be irrational. But when it's negative, we say that this is non-real roots, and therefore there are no intersection points. Intersection points. So it basically means that you can't solve this in the real numbers. And so we say there are no real roots, and therefore there are no intersection points. So this is possible. It doesn't come up all the time, but basically this means that if we had to draw this graph, let me have kind of a... How do you find delta? Delta is the thing inside the square root bracket. So delta is b squared minus 4 times AC. Oh, did I make a mistake? Sorry, I made a mistake there. You're quite right. I made a mistake with my subbing. So actually, even though it's a useful thing, let me redo that. I noticed I made a little typo there. So when I go minus b, I go minus 5. And then I go plus minus, and then I have b squared. So that's going to be, oh, did I really completely get that wrong? It's going to be b squared is 25 minus 4 times 1 times minus 1. That looks a bit better. Sorry, everyone. Did you see how I substituted in there? B squared, so minus b plus minus, then this should be minus 5 squared, which is 25. So I could even write this as, I wonder what I was doing there. And then I have 2 times 1. You know what I did wrong, everyone? I was looking back at the original function by itself. And the problem was I was looking at the original function. I wasn't looking at the function here. And that is a problem. So give me a thumbs up if you understand why I should be looking at this one and not at that one. It's kind of important. Okay, so if I look at this now, I get 5 plus minus, and then over here, I'm going to get 25 plus 4. And then on the bottom here, I'm going to have 2 times minus 1. And so I should get minus 2. Let's just make sure, yeah, 2a. So it's 2 times 1, not minus 1, because it's not a c. So 2 times 1. And so that would be 2. And so then my final answer would be 5 plus minus the square root of 29 over 2. And then to get the actual answers, I'm going to get x is, and if you could just check this for me, I should be getting, it's going to be about 5.19, or the other one is going to be the square root. So the square root of that is going to be less than 5. So it's going to be quite a small number, minus 0.19. So give me a thumbs up if you have got that. And then to get the y value, all we need to do is take the x values and put them back into one of the original equations. And of the two equations, I think the simplest one is the straight line. And so we are going to say 5.19, and then we'll get the y value. And then the other one, we are going to put in the minus 0.19, minus 4, and we'll get an answer for y here and an answer for y here. What are you getting for your y values? What y value do you get goes with 5.19? and what y value goes with. Punch it into your calculator and see what you get. Okay, so what I did for Tekel is I took this value down here. That's the one solution to the equation, the intersection point, and then this one is the other. And what I did was I substituted those into one of the two original equations. So if you look at the original, the one that I've made use of is this one, minus 3x minus 4. And so all that happens is where there was an x, I've put these answers over here. Does that help? So I can do it too. So if I go minus 3 times 5.19, and then I take away 4, I get minus 19.57. And then for the other one, minus 3 times minus 0.19. That ends up being positive, and then I take away 4, and I get minus 3.43. And what that means is the intersection point that goes with x is going to be, I mean, the y value is going to be minus 19.57. Over here, y is going to be minus 3.43. Yes, Irene, we are on the same page. Now, that was a bit of a toughie to start with today. But yeah, if you think about the method, we've equated them, and then we just had to do some algebra to go through these steps. So Fateka was asked, what happens if delta is unreal? So exactly what I did when I thought delta was unreal. If delta, this thing inside the square root, is negative, what that means is there are no intersection points. It means you cannot solve the equation. However, if delta is not square, then you get irrational roots like this. And if delta was square, you would just get rational roots. Okay, let's move on to another typical type of exam question where you're given a graph to start with. So let's start. Actually, no, I like the look of this one over here more. Let's start with this one. Okay. The two types of graphs that are involved here are what? What type of graphs are involved in this question? Exponential, yep. So that's the exponential. I noticed the x floating in the sky. And then this one over here is a parabola, but it's in the alternate form. All right, I want you to find me OE and OD, which are distances to start with. Nicely done, Saskia. So off you go. See if you're able to do the first two, keep going. We're going to do all the questions here. Where is O? O is over here. So O is the origin. So OE would be that distance, and OD would be that distance. So you need to think about what relationship in the formulas do you need to exploit to help you here. Okay, so I think that OE is an x-intercept of the parabola. And so one of the things I have to try and do is find the x-intercept of the parabola. So that's the one thing you're going to do. And then OD is the y-intercept of the yellow one. So I'm going to wait a bit longer for people to put their answers in the chat, but that's the hint I'm going to give you. So the x-intercept of the parabola, and to find the x-intercept, we normally have to solve that question. And to find the y-intercept of something, we would normally have to make x 0. And so I think you would have to solve that question. See what you can do. When you solve this equation, there's a couple of ways you could do it, but I think I'm going to do it like that. And then I'm going to times both sides by -1, and then I'm going to get that. Now, I don't know if everyone will do it this way, but it is slightly quicker. Otherwise, what you need to do is you need to multiply all of these things out. But you can square root both sides at this point, but you need to remember that there will be a plus and minus root. So if you square root 4, you get 2, but you also get -2. And so 2 would be equal to x minus 2, or -2 would be equal to x minus 2. And then x is going to be 4, or x could be 0. Which one, the 4 or the 0, is helpful? Tell me in the chat which of the two you think is helpful. It's the 4, yeah. Because we know this must be the 0 here, and that must be the 4. So what is OD going to be? And what is OE going to be? This is such a nice question. It really forces you to think. What do we think? So if D is -2, then it can only be 2 units. Because we don't, with distance, you don't have a negative. And with OE, it's going to be 4 units. Okay. Right, let's see. Can you do the next two? So the next one is OC. So can you find OC, which is this distance over here? And can you find, well, let's do that first. Let's do OC. What do you think is important about C? If you look at this question, what is special about C that maybe you could use to help you figure out what its coordinates are? That is what I am curious to know from you as a group. So you don't have to answer it, but what is special about C? It's a right angle, yes. I'll ask you this, what graph is it on? What graph is it on? Is it on the function f, or is it on the function g? Which of the two functions does it lie on, the point C? Yeah, it's on the function g. Okay, so we know that that's what we're playing with. What else is important about c? I think that c looks like where it cuts the x-axis. So really, the point c is going to be the x-intercept of g. And to find the x-intercept, we need to make y equal to 0. So I want you to try and solve that equation for me to find what c is to then unlock the distance of OC. Who has a first step? What do you think, Shakira or Saskia or Saba? What would you do? I'm feeling like the 4 comes across and I get that. Now, what does x then have to be if I look at this comparison? Aha, yes. Tejo, you're on it. So this could be 2 squared. That could be x plus 1. So therefore, x is 1. And if x is 1, c is 1, and then OC would just be 1 unit. Awesome. So we've done those 3. Okay, we're going to do 2 more before the break. I want to do BC next. So where is BC? BC is this distance over here. Now, in order to find this, I need to find what the y value is of this point B. Who can tell me the y value of this point B? Or what idea? Josh, that was quick. So Josh has said that the x is 1 can be plugged into f. So let's have a look. You're right. B is directly above C, and C is 1, and B is on the function f. So I want to know what is the f of 1. And you'll notice that I have just put a 1 wherever there was an x. So tell me, what is the f of 1 for this particular question? And then as a result, what is BC? So that is going to be 1 to minus 1 squared plus 4. And that is going to be minus 1 plus 4. And that is going to be 3. So indeed, that is 3. And BC would be 3 units. Okay, last one and the toughest one, FG. If I want to find FG, FG is the distance between here, oh, this is a toughie, and here. Well, okay, it's not actually that bad, but if you want to find, let's have some ideas. We can do this together collaboratively. Where do you think we should start for FG? What's noticeable about FG? Oh, Josh, you know your functions. How did you know minus 4? Where did that come from? How did you know minus 4 was important? So I think what Josh did, Josh looked at this top bit over here, the asymptote, yes. So you'll notice that there's a minus 4, and that minus 4 relates to this asymptote. So the equation of the asymptote would be that. Now, what I can do is I can say, look, that point F is on the parabola, and that point G is on the parabola. And I want to know kind of when does that function equal minus 4. So what I'm going to do is I'm going to say, look, when is the parabola, which is this thing over here, equal to minus 4? And so if we solve this, we can figure out what f and g are. Now, I'm going to show you the longer way to do this because last time I used the quicker way. So the longer way is to literally just multiply it out, where you get minus 2x plus 4. And then that's also going to be a plus 4. And then we're going to get minus x squared plus 2x minus 4 plus 4. And then what do we have? We'll bring this across and we get minus x squared plus 4x plus 4. And you know what? I prefer it to be on the other side. So I'm going to move everything across and I'm going to say x squared minus 4x minus 4 equals 0. What is the answer to that going to be? What is the answer to that going to be if I want to solve that quadratic? And then we're going to have a break. Can I factorize that? 4 and 1, no. 2 and 2, no. I think I need to use the quadratic formula. So I'm going to go x is minus 4. And then it's going to be b squared. So 16 minus 4 times 1 times minus 4 over 2 times 1. And then x is going to be, it's going to be a irrational root. There's going to be 2 of them, though. So it's going to be 4 plus, let me do this. I'm going to get 4 plus square root 32 divided by 2. And I get 4.83. Or I'm going to get 4 minus square root 32 divided by 2. And then I'm going to get x is minus 0.83. Now, and Emmanuel has got exactly the same as me, which is great. And so is Fateko. Now, obviously, that is just the x values that I was looking for. So I know that this one would be the minus 0.83 and that this one would be 4.83. What's the y value going to be? The y value has to be minus 4 because you can see it's on this line. And so the y value has to be minus 4. Now, in this question, all I wanted to know was what is the distance FG? So what is this distance going to be? Well, I'm just going to have to say 4.83 minus 0.83 or add 4.83 plus 0.83 because it's a distance and I get 5.66. And so FG is 5.66 units. Give me a thumbs up if you followed that question. Give me a thumbs down if you didn't follow it. That was a bit of a toughie, but why did you add? What did I add? I basically went 4.83 minus 0.83, which is basically it's like saying I need the distance from here, but then I also need that distance over there. So what I suggest is if you found that question a bit difficult, I would look at the recording or I would look at one of our earlier videos, but that was tough. So, it's part of being, we do challenge a little bit more in the standard class. Okay, we're going to take a break now. So if you could join me in standing up, turn on your cameras. And I know that you are feeling like, oh my gosh, this is end of the week syndrome, but just hang in there. We're only going to do 1 or 2 more questions and then we are done for tonight. But we know we want to do some exercise just to unwind a bit first. So let's take some deep breaths. Another one. Another one. And one more. Okay, then let's shake out our arms, shake out our legs, and let's start with some small circles going into big circles. And let's change direction. Big circles going into small circles. Shake it out again. You really want to get the circulation in your body moving. Like when you sit for half an hour, your body kind of starts to go to sleep. So just, your foot sometimes goes to sleep. So just shake out your foot a bit. You just want to get the movement going. Okay, let's rotate a little bit. So just some gentle rotations. And then as you feel looser, you can start turning more. Okay, then we need to get the blood pumping. So we're going to do some jumping jacks. So make sure the space around you is clear, that you're not going to whack anyone or anything. And a jumping jack is just like this. And let's see if we can handle 20. I don't know if we'll get there, but we can try. So we start in 3, 2, 1. Let's go. And that is, I think, enough to get your blood moving in your body. So now that you've got some oxygen and you've got some blood flow, your brain should be a happier camper when we start learning again. And let's just do a little Math 24 puzzle before we move on. And just let our heart rates come down. What we're trying to do is we're trying to make 24 using the numbers on the card. See if you can do that. Okay, Emmanuel has said, and I think this is for the second, the blue one, 3 minus 2 is 1. And then, okay, 8 times 3 is 24, and you just times it by 1. So that belongs to Emmanuel. Can anybody do the yellow or the red? I'll give you 30 more seconds and then I'm going to move on. But anybody else? So for this one, I think we would have 8 times 4 is 32. How do we get rid of these other ones? Well, we go minus 8 times 1, which should give you 24. Yeah. Okay, so I hope you're feeling good. Oh, there we go. And Emmanuel's got the yellow one. Look at you. 9 minus 7 is 2. And then 5 minus 2 is 3. And then 3 times 8 is 24. So you're quite correct. Yeah. Okay, well done, Emmanuel. So let's go back to something a bit more focused. Let me just move this out of the way, and then we will go and look at, oh, oopsie daisy. So this is taken from a Department of Education paper from 2016, once upon a time in a land far, far away. And if we look at this question, it says that we've got the graph 2 times bx plus 1 plus q. And so we're missing the b value and the q value. It then says the graph passes through the points 120, so that is 120, and also the point -1y, which is down here. Show, this is interesting, show that the equation of f is that. So what they're basically saying is you need to show us why does b equal 3 and why does q equal 2. Okay, where would you start for this question? So this is a bit of a more interpretation thinking question. Where would you start? Sub in A. Yep. I would do that, Josh. The other thing is I know that Q has to be 2 because of the asymptote. So I would start by saying, look, Q is 2 because I can see the asymptote. So Q is 2 because of the asymptote. And so f of x has to be 2 times b, x plus 1 plus 2. And then you ask yourself, what other information is given? Well, they give you that a is 120. So what I'm going to do is I'm going to put a 20 here. The b stays what it is. That's going to be a 1, and then a plus 2. And so what I've done is I've essentially put that 1 over here. And now I need to solve that equation for b. So how would I do that? Well, I would move things across. So first of all, I would get 18 equals 2 times b squared. And then I divide by both sides, and 9 would be equal to b squared. And then if I square root b, b would be plus or minus 3, but I'm not allowed to have a negative base in an exponential. So I have to exclude the -1, and b must be 3. Okay, so that was that one. Find me the y coordinate of b using the fact that you now have this equation to work with. Find me the y coordinates of b. What is the y coordinate of b going to be? So it feels like I just have to sub this in. So if I have this is on the exponential graph, so we know what I need to find what the f of -1 is going to be. So I go 2 times 3 minus 1 plus 1 plus 2. But now I know anything to the power of 0 is 1. So that becomes 2 times 1. So 2 times 1 plus 2, and that becomes 4. And so B must be the point -1, 4. Yeah, Josh, Emmanuel, looking fantastic. Who else we got it going on? Yeah. Okay, yeah. All right, next question. I want you to write down the range of f. And I also want you to find the coordinates of the y-intercept of f. So I want you to do the next two questions, which are in green. What is the range? Now, range deals with y values. So we know there's going to be a y. Is it going to be a less than or greater than? And what number is going to be involved? I feel like this value, this exponential never goes below this value over here. Now, so the y value is going to have to be greater than, not equal to, because it never gets there. That's an asymptote. Y is going to be greater than 2. And I see Emmanuel definitely agrees with me. So that we're on the right track there. And then the last one, is this graph increasing or decreasing? How do we define an increasing function or decreasing function? How do we even know? Oh, wait, I need to, before I do that, I need to actually do 5.4. So for 5.4, I need the y-intercept. Now to find the y-intercept, I always make x 0. I know what the graph is, so I've got the formula up here. The f of 0 is 2 times 3, 0 plus 1 plus 2. I then know that that becomes that. I then know that becomes that, which is 8. And so the y-intercept is going to be 0, 8. So that would be 5.4. Okay, last question of the day. Is the graph increasing or is it decreasing? What do I need to look at to tell whether a graph is increasing or decreasing? Is this an increasing or decreasing exponential? You do look at the shape, but what do you look at about the shape? What do you have to do? You look at the value of b, yes, that's it. And you can also look at whether the graph read from left to right, yes. So when we talk about increasing, like when we read on the page, we read from left to right. If you go from left to right and it's going up like a plane taking off, we say it's increasing. If you're going from left to right and it's going like this, a plane coming for landing, it's decreasing. And so we would say that this function is increasing. And if you wanted to provide a reason, yes, the thing that you would need to look at would be this value. And so because that value is greater than 1, you can say b is greater than 1, then it would be increasing. Okay, so this is an increasing function. Now, I've got one more question I'm going to make myself. It's going to be a remix. I want you to reflect this graph. I want you to find me the reflection of f in the So I'll say, find me the equation of the reflection of f in, what axis should I reflect in? Reflected in the x-axis. So this is the last question. I want you to take the graph f, and I want you to find me the equation of that, but I want you to reflect it in the x-axis. So reflected in the x-axis, you can kind of visually see that graph is going to look like that. But the question is, well, how do I actually find its equation if I want the reflection of f in the x-axis? Who has some ideas? So if you want to reflect something of the x-axis, there's a golden rule. What's the golden rule? When reflecting over the x-axis, you need to change the sign in front of y, or the opposite variable. So I go to my formula and I say minus y equals 2 times 3 to the x plus 1 plus 2. But now the standard form will have the negative on this side. So I multiply both sides by -1, or I divide both sides by -1, and I should get that. And so that is the reflection of that original graph in the x-axis. Okay, it's going to look like that. Now, this reflection, is this reflection increasing or is it decreasing? What type of function is this reflection going to be? Is it an increasing function or a decreasing function? Nicely done, Boitumelo. Oh, Kakliso, you're also nailing it. And then Bonolo, perfect, yes. So the reflection is going to be a decreasing function, because you can see as you move from left to right, okay, you're going to be going down there. All right, everyone, that is it for today.